This video is about exponential and logarithmic functions and how to go back and forth between the two. So there is a relationship between the exponential and the logarithmic function, and it's really important that you know how to go back and forth between these two types of functions. So the exponential function is f of x, or, well, we can just call it y, equals some base number raised to the power x. And the equivalent statement in log form is log base b, so this is a little subscript, and so this b in this equation for the exponential is the same as this b in the logarithmic. And the statement that I always remember to help me remember how to go back and forth, and so the base I think is easy to place. So the base is the number in the exponential being raised to a power, and it's a little subscript of the log. And then if you just remember that logs are equal to the exponent, then you'll know where to place the x. So this log is equal to the x in the exponent here, and then you're taking the log of the number y. So again, the statement to remember is that logs are equal to exponents. Well, let me get that written better. So again, if I remember this statement, then this b is easy to put in its place. The base of the exponential statement is the base of the log. And if I remember that logs are equal to the exponent, then I know where to put the x. And we're taking the log of the number y. So next we have some properties of logs. So the first property is log base b of 1 is equal to 0. And so if we rewrote this in exponential form, then the thing being raised to a power is the base of the log, so it would be b, and then remember logs are equal to the exponent, so it's going to be raised to the 0 power, and it's equal to 1. And so that was one of our properties of exponents also, is that anything raised to the 0 power is equal to 1. The next property is that if you have log base b of b raised to the x, then this is equal to x. So remember, b is the thing that's being raised to a power. And I'm going to color coordinate this because there's a couple of b's and a couple of x's in there so that you know where the b's are coming from. So we have b, that b, being raised to the power of x. And so there's where the exponent is coming from for this. And it's equal to b to the x. And this b to the x was this b to the x right here. So that's rewriting it in exponential form, and so you can see that it produces a true statement. B to the x is really equal to b to the x. So one example of this property would be if you had like log base 3 of 3 raised to the x minus 1, then this log would be equal to x minus 1, the exponent here. And this next one is b raised to the log base b of x is equal to x, and so the only way that I can think of to explain why this one is true is just to rewrite it. Right now it's written in exponential form because we have some number being raised to a power, so that means that it's in exponential form. And so we would want to rewrite this in log form. So we would have log, and then the base of the log is the same as the base of our exponential, so that would be this b. And logs are equal to the exponent. And the exponent here is log base b of x. And we're always going to be taking the log of whatever this thing is equal to, the x. Okay, so when you rewrite this in log form, then you get a true statement. You get two logs that are equal to each other. Here we're going to evaluate the log expressions. And so our first example, we have log base 7 of 49. And when you're evaluating a log, you want to know, well, logs are equal to exponents, so what power can I raise 7 to so that I get 49? So that's what we need to answer here, and the answer to that is, or the question mark is 2. 7 squared is equal to 49, and so log base 7 of 49 is equal to 2. Our next one, we have log base 16 of 2, and so we want to know what power can I raise 16 to so that I get 2. Well, this one's a little bit harder because now I'm going from 16, I want to raise that to a power so that I get 2. So I need to get smaller, which means that this question mark, or this power, is going to have to be a fraction. So basically I want to know what root of 16 can I take so that I get 2. Well, it's not the square root, because the square root of 16 is 4. And you can't take the cubed root of 16, it's not a perfect cube, and so we're going to guess that this might be the fourth root. So will the fourth root of 16 give me 2? Well, so we want to know, is 2 times 2 times 2, 4 of them, going to give us 16? And it does. 2 times 2 is 4, times 2 more is 8, and then times another 2 is 16. And so the answer here is 1/4. The fourth root would be 16 raised to the 1/4 power. And our next example, we have log base 5 of 1 over 25. So I want to know, what power do I need to raise 5 to so that I get 1 over 125. So this number is down in the denominator, which tells me that I want an exponent that's negative. So this negative exponent means that I'm going to get 1 over whatever power I raise 5 to, and 5 raised to what power is 125? Well, the answer there is 3. So negative 3 is the power of 5 that will give you 125. In our next example, we have log base 3 of 1/9. So I want to know, what power can I raise this base to, 3, so that I get 1/9? Well, again, we want the 3 to end up down in the denominator, so I know that I want that exponent to be negative. That's going to bring the 3 down to the denominator, and what power of 3 will get me to 9? And the answer there is 2. And so log base 3 of 1/9 is negative 2. Our next one, we haven't talked about E yet. We'll just talk about it kind of briefly here. E is, should be a button on your calculator for E. And so E is a number that's a lot like pi. So most people have heard of what pi is, but some people have not seen E. And I'm not going to go into how we get E, but E is approximately 2.72. And again, you should have a button on your calculator that's e to the x. And it's usually somewhere near or the same button as the ln button. And we'll talk about what this means in another video. So basically this is a number. It's a lot like pi. It's approximately 2.72. And this is just using one of our properties actually, but you could just think about this. Well, what power do you want to raise this base e to so that you get e to the x? And the answer here then is just x. And again, this was also this number 2 property that we had up above. Here we have log base e of 1 over e. So again, what power can I raise e to so that I get 1 over e? Well, all I need to do is drop that e down to the denominator, and so e raised to the negative first is equal to 1 over e. So that would just be negative 1. In our next example, log base 11 of the square root of 11. So what power can I raise 11 to so that I get the square root of 11? Well, the square root of 11 is 11 raised to the 1/2 power, and so the answer here would be 1/2. And our last one of these, log base 0.5 is equal to 0.125. So what power would I have to raise 0.5 to so that I get 0.125? And the answer there is, you can just try powers of 0.5 if you want, but it would be 0.5 raised to the third power would get you 0.125. Now we want to write each of our logs, each of these as a logarithmic equation. And so our first one, 5 squared is equal to 125. So again, this base 5, and we'll do some different colors here. Sometimes that'll help people visually. So the base of this exponential is 5, so that means the base of the little number of my log is going to be 5. Logs are equal to exponents, and the exponent of this is 2, and so this log is going to be equal to 2. And then there's only one other number to put in its place, and that's the 25. Okay. All right, so our next one, we have 2 to the 5th is equal to 32, so we want to write this as a log equation. So logs are equal to the exponent. Well, first let's write in our base. So the base of the exponential is 2, so that means the base of this log has to be 2. Logs are equal to the exponent. So there's my exponent, it's 5, so that means this log is going to be equal to 5. And then the only other number we have left to put in its place is the 32, and so I'm going to be taking the log of the 32. And so we'll do a couple more. So we have 10 to the negative second is equal to 0.01. And again, the base of this is 10. And so the base of my log is also going to be 10. Logs are equal to exponents, so this log is going to be equal to this negative 2 that is in my exponent. And the only other number you'll have left to put in its place is a 0.01. And one more of these. So 10 raised to the 1/3 is equal to the cubed root of 10. And so 10 is my base, so 10 will be the base of my log. Logs are equal to the exponent, so this log is going to be equal to this 1/3. And the last number to put in its place then is the cubed root of 10. So log base 10 of the cubed root of 10 is equal to 1/3. And that ends our lecture on going back and forth between logs and exponents. Let me know if you have any questions.